I'm making general example. Compute percentage error in the following function when x variable contains error of amount uh, amount uh, let's say 0.01, and y variable, it could be a current or voltage, anything. So do not memorize thing, just learn the concept. And y variable have an error of amount 0.001. Let's say the function that is given to us is defined like that. Y sorry y is a variable, so let's say z is a variable which is depending on x and y, and the function is z, for example x square y plus xy something. Now what we have to do, we have to compute the error in this function. So for error, as we know, this is depending on more than uh, one variable. So what we can do in this case is we can try to compute the error based on the formula, that number 2 that we have learned today. So uh, error in the function, so we can say error in z variable, z variable is epsilon z, and it is defined as epsilon z is equal to epsilon of x partial of f of x plus epsilon of y partial of x and z. So in this case, just to save space, that would be epsilon x is like that, and what I have to do, I have to compute the partial derivative of this function plus epsilon of y, and I have to compute partial with respect to y of similarly same function. So how do we do that? It's very simple, just compute these quantities. So partial derivative with respect to x, treating x as a variable and y as a constant. So in this case the derivative would be 2x y square plus y. Similarly epsilon y, in the other case derivative is partial with respect to y, so treating y as a variable and other, that is x, as a constant. So if we do so, that would become uh, 2y plus 2y x square plus x. Now we know the value of epsilon x. Epsilon x in this case is 0.1, and similarly epsilon y is 0.001. Sometimes it is given clearly, sometimes not, but let's say it is defined like that in this example. So 0.01 multiply by the quantity that we have plus the epsilon y is 0.001 multiply by the quantity we have here, that is a change in y, change in f respect to y. So what I need just to get the absolute error in a numerical value is just the true values of x and y. So if I said I want to compute the error at x equal to 1 or x equal to 2 something, or y equal to 1, y equal to -5, you just need to put x, those values of x and y here. That is a true value. So you will get a numerical answer. So point that I want to show you that this is the simple process to compute these quantities. It is not that difficult task, but this could be done easily. So this is the epsilon y. So this is just a very simple concept. Today we have learned how we compute the derivative in this case. I hope this is an easy topic you have understand. I will share some exercises with you. You have to try them. It is not that difficult part. You just need a partial derivative and some definitions that how to express them as a relative or percentage error or some other errors. This is very simple topic, but this is one of the key topic as well, that how the error propagates in the calculation, whether it's a numerical values or a functions, and how do we handle them. I hope you understand that part. In the second part, here we basically end the error analysis topic. Now we have to continue with other topic, which is the operators. So if you have questions related to that part, you can also ask the questions in the first week live session, that is the week after the first week. So note down the questions that you have. Now let's move to the other part, and we call it operators.